Have you ever noticed that your coffee never quite tastes as incredible as it smells? It's kind of this tiny tragedy we all face every single morning. You walk into your kitchen, take a massive deep breath of those freshly ground beans, and your mouth just instantly waters. But then, you finally take that first sip. And I mean, it's good, right? But it doesn't completely match the absolute majesty of that aroma. Well, you are not crazy. Today, we're going to look at the hard science behind why this happens, and trust me, the answer is absolutely fascinating.
Welcome to today's Explainer, where we are breaking down the hidden science of your morning coffee. We're going to explore how a simple cup of dark liquid is actually this daily miracle of psychology, chemistry, thermodynamics, and human anatomy. We are pulling directly from deep dive scientific sources, including research from Monash University, the American Chemical Society, and various sensory experts, to map out exactly what is happening in your brain and your mug every single morning.
Here's our roadmap for this explainer. We'll start with the mind's caffeine buzz, followed by the chemistry of roasting. From there, we'll decode coffee flavor profiles and look at the temperature flavor dance. Finally, we will solve that ultimate mystery, the smell versus taste paradox. Let's jump right in. All right, starting off with section 1, the mind's caffeine buzz. Before a drop even touches your lips, your body is already reacting to it in some pretty wild ways. Okay, so there's this fascinating psychological concept called mental construal. Basically, it's how we process information, whether we're looking at the big picture or zeroing in on narrow details. Researchers at Monash University and the University of Toronto actually conducted a massive study to see if we could get a caffeine buzz without ingesting any actual caffeine. And you know what? The answer is yes. It's a classic Pavlovian dog response. Because we habitually consume coffee, our brains are literally conditioned to respond to its cues. Just smelling coffee grounds, walking past a cafe, or even seeing a coffee advertisement triggers this mental construal effect. It heightens our arousal, bumps up our heart rate, and forces our brain to focus on narrow details. Your brain is handing you a placebo caffeine buzz just from the anticipation.
But wait, it gets even wilder. This mental boost, it's heavily dependent on your culture. The study exposed over 800 participants from both Western and Eastern cultures to coffee and tea cues. In Western cultures, where coffee is heavily tied to ambition, energy, the whole productivity grind, the cognitive-altering placebo effects were significantly more pronounced. Participants actually experienced way greater arousal and alertness from coffee cues than from tea cues, purely based on those cultural associations. So that morning buzz of yours is heavily rooted in your psychological and cultural conditioning.
Let's move to section 2, the chemistry of roasting. Now that your brain is primed, let's talk about the physical matter. A raw green coffee bean literally tastes like grass. It takes a violent, fiery chemical transformation to turn it into the beverage we love, and it all happens in highly precise temperature stages. Between 150 and 200 degrees Celsius, sugars and proteins begin to react and caramelize. Then, at 205 degrees, we hit the first crack. The water inside the bean actually vaporizes, expanding the bean to double its size with an audible pop. As the heat rises to 220 degrees, a process called pyrolysis kicks in, releasing carbon dioxide and turning the bean a medium brown. Finally, around 230 degrees, we get the second crack, where the actual cellulose in the bean's cell wall breaks apart, bringing this beautiful, oily sheen right to the surface. According to the American Chemical Society, the true hero of this whole process is the Maillard reaction. This is where carbonyl groups from sugars and amino groups in proteins violently collide to form hundreds of complex aroma and flavor compounds. One of the most potent ones is a compound called 2-furfuryl-thiol, which is heavily responsible for that classic, unmistakable roasted coffee smell. If you roast too lightly, the bitter-tasting compounds won't degrade, but hit those exact right temperatures and you build the absolute perfect body and flavor. Which brings us perfectly to section 3, decoding coffee flavor profiles. How do these exact roasting temperatures actually dictate what we taste in the mug? The crucial point here is understanding what experts call the flavor triad: sweetness, bitterness, and acidity. As outlined by the coffee pros at Frothy Monkey, these 3 pillars are directly manipulated by the roast. Light roasts are going to heavily highlight bright acidity. We're talking citrus, malic, or tartaric fruity notes. As you push into darker roasts, that acidity drops off and bitterness is enhanced. Now, quality coffee should actually have minimal bitterness, but cheap, low-grade coffee is often intentionally roasted super dark, specifically to mask unpleasant, defective notes. And then there's sweetness, often showing up as caramelized sugar or chocolate notes, which is the ultimate balancing act right in the middle. To truly appreciate all this, you've got to actively engage your senses.
To quote the Frothy Monkey Guide, tasting coffee like a pro involves building experience through experimentation with different flavors and smells. Don't just drink your coffee passively. Treat your kitchen like a professional tasting lab. Really pay attention to how a light roast feels completely different from a dark roast on your tongue. It's a skill you can easily build up over time. Now, grab your freshly brewed mug, because we are hitting section 4, the temperature flavor dance. Your coffee's flavor is actually a moving target. The thermodynamics experts at Livru map out exactly why your coffee tastes totally different as it cools. At high temperatures, above 70 degrees Celsius, steam causes a massive, rapid release of aromatic molecules. It smells amazing, but your tongue actually has limited complexity at that heat. The temperature literally masks the sweetness. Then, as it cools down to between 55 and 65 degrees, we enter the golden zone. This is the sweet spot where sweetness peaks and perfectly balances out the acidity. Finally, at low temperatures, down near human body temp, something really interesting happens. Acidity becomes incredibly sharp, and fine coffee particles form these colloidal flocks that absorb aromatics and release bitter molecules, bringing back a powdery bitterness. This temperature dynamic completely changes your drinking experience based on how you brew it. Think about an espresso. It's a tiny volume of liquid, so its temperature drops super fast. That means your golden zone sweetness window is incredibly short, and bitterness returns really quickly. A pour-over, on the other hand, is a much larger volume of liquid where the temperature drops gradually. This lets those flavor layers unfold slowly over 10 or 15 minutes, giving you a long, sustained evolution of acidity and sweetness. And finally, we arrive at section 5, the smell versus taste paradox. Let's answer the big question we asked at the very beginning of this explainer. Why is the taste always a tiny bit disappointing compared to the smell?
The secret lies in human anatomy, specifically a theory championed by Professor Barry Smith. Get this, we actually have two completely different senses of smell. There's inhaling, bringing odors from the outside environment into the nose, but when you swallow liquid, air is forced backward up your nasal passage from inside your mouth. This is called exhaling, or retronasal olfaction. Our brain's receptors react to the exact same odor completely differently depending on which direction it is traveling. Think of a stinky cheese, like epoisses. From the outside, it smells pretty revolting, but from the inside out, your brain registers it as delicious. Coffee is the exact opposite. From the outside in, it's heavenly. From the inside out, the brain is just way less receptive to the flavor. In fact, only 2 aromas in the entire world, chocolate and lavender, are interpreted exactly the same way in both directions.
But anatomy plays one final, kind of cruel trick on us, to the tune of a staggering number, 300. Coffee has an incredibly complex aroma made up of 631 different chemicals. However, the exact second the coffee enters your mouth, enzymes in your saliva instantly wipe out 300 of those 631 chemicals before you even have a chance to swallow. Nearly half of the complex aroma that you just smelled in the air is literally destroyed by your own biology the moment it hits your tongue. So let's wrap this all up. When you enjoy your morning cup, you're actually participating in a massive multidisciplinary event. First, your brain gives you a psychological placebo buzz just from your cultural cues. Second, those beans underwent violent chemical roasting reactions, like the Maillard reaction, to build that flavor triad of sweetness, bitterness, and acidity. Third, as the coffee cools from hot to room temperature, thermodynamics completely shifts the flavor profile across your tongue. And finally, your own saliva and the directional flow of air in your nasal passages biologically ensure that the taste can never quite match that incredible scent. It's almost magical when you break it down like this, isn't it? Every single sip is literally a masterclass in science. So I'll leave you with this question. How will your newfound knowledge of retronasal olfaction, saliva chemistry, and the thermodynamic golden zone change how you approach your morning brew tomorrow? Maybe you'll wait a few extra minutes for it to cool to peak sweetness, or maybe you'll just appreciate that amazing 631 chemical aroma a little bit more before you take that very first sip. Thanks for hanging out with me for this explainer, and keep asking those big questions about the little things in your day.